Okay, so let's look at the journey now. We started with 1883 all the way to 2018, 135 years of innovation where you have seen so many things happen. Before that time, almost nothing happened. Millennia, we had just the same structure. We had the masonry arches and we have masonry arches. That's just about it. And then suddenly we have so many systems, so many technologies developed until CITIC Tower, where we combine so many things. But so you can see here, we have the metal era, Eiffel Tower, and the Brooklyn Bridge, concrete. Then we have the thin shells era, then tubular systems, and now we have the advanced systems. So we are very quickly, we have gone through so many iterations. So what's next then? There's still one project that is interesting, and that is the Dubai Creek Tower. Because this tower is very different from anything anyone has ever designed or built, because this combines the cable stayed or bridge technology with the tower technology together and then creates this super thin, super tall structure. And it's under construction, as you know, has been delayed a lot, but this is really, it's not finished yet, so I did not include it in the main presentation, but I just want to show where the things are heading. And this is a cable-stayed concrete core tower, very tall. We don't know the height. They keep changing the height. Sometimes they say it will be higher than Burj Khalifa. Sometimes it's no, cannot be, because that's the limit in Dubai, and so on. So there's still a debate what if the total height will be. But it's a very interesting concept. And as you can see here, it's a cable net. It resembles petals of a flower. It's just tied together. It's a net around that. It's just, and look at the towers itself is very thin, very slender. So stabilized by cables. And this is designed by Santiago Caltarava. I met him in Dubai when he showed this project once again in the CTBUH conference, and we just talked briefly about his concept. And he's an architect engineer, so he's a structural engineer and also an architect. So most of his projects are beautiful because he combines architecture and engineering together at the same time. And his designs are really very beautiful, both bridges and buildings. Okay, so let's see how this building completes. Now, let's conclude and go back to the beginning. Now we have seen so many buildings, so many technologies, so many systems. But if you notice one thing, flowing through all of them is the same, is the force flow. That has not changed. So we still have to look at how the forces flow in every structure. Is always the same, how the forces are flowing. We are not concerned about stresses globally. We are concerned about the global force flow system. Inside, we can manage. And I showed you that project, the first one in 1890, that bridge was made, and I showed you the pictures with just having tension compression, this one. And then they built another bridge in 1964, same concept, just tension, compression, just slightly changed the way tension and compression is handling. They made a cable-stayed bridge, they made a suspension bridge there. And then in 2017, made another bridge at the same location, now cable-stayed bridge. Once again, tension, compression, same concept, same thing happening again and again and again, just slight change in technologies. But the concept of the force flow hasn't changed, because that's the physics, that can't change. So if we focus on the force flow, then look at the solutions, we will find many variations. So with that in mind, and this is a picture I took of those two bridges, just to see, you can see here how suspension bridge and cable-stayed bridge side by side look like here. And so I would conclude that it's always going to be about finding the most efficient and elegant way to manage the force flow, no matter how we look at it, what we do. The tools and technologies are just means to accomplish that. We have seen it changed over time, but the concept is the same. Mega frame, having the same, all of the structures trying to find the best, most elegant and most efficient way to manage the force flow. That's just about it. Thank you.